Retrieval Augmented Generation, RAG. Imagine giving a chat application or a robot the ability to browse the internet or databases to provide you with responses. This is where RAG comes into play. And here's a gist. When a user poses a question, instead of relying solely on its internal knowledge, the model will send a query to an API, an application programming interface. And through this interface, we benefit from the results to construct a more comprehensive and informed response. What makes RAG great? Well, unlike the costly and complex model fine-tuning or even training process, RAG is a straightforward technique that quickly yields noticeable results. What's easier when you search for a topic in the library? Will you go through all the books that are available? Or would you go to the librarian or the computer to search for a specific book that answers your questions? This is what we achieve through RAG. For companies, instead of mining through piles of documents to train or fine-tune a model, we can simply store them in something called a vector database. When a query is posed, the model can retrieve relevant information and present it to the user in a simplified form. RAG versus fine-tuning. Use fine-tuning when you need to improve or adjust the model's behavior, and you would choose RAG when you want the model to benefit from external sources to provide the appropriate response. We start our journey with a simple example, address the challenges, and then move on to more advanced examples. Let's go. First, we load the models and store the API key. And now let us try this example where we send a question about who's the CEO of Twitter in 2023. Now obviously, when using zero-shot, the responses depend on the model's training, which is limited to the information available up to the training cutoff date, for example, September 2021. Now, let's introduce a function that allows us to leverage DuckDuckGo and then modify the prompts in a way that enables us to display the query and search results simultaneously. Great, now with the function at our disposal, let's start the task by first sending our question to DuckDuckGo. Then we present the modified prompt to the model. And as you can see, now we have the appropriate response. Let's dive into the challenges for such applications. Challenge number 1, simplifying complex queries. One notable problem relates to integrating all of these texts with your question just to extract a simple, concise answer. This not only affects API operations due to the maximum token limit, but also increases the cost because you're going to be paying for all of this. Therefore, we can use modules like GPTrim to compress or reduce the text by up to 50% by removing spaces and stop words. And remarkably, the models such as GPT-3 and 4 remain adept at understanding the texts and responding effectively. Challenge 2, converting user messages into search queries. As you may have noticed, accepting the user's message as is does not always yield the perfect result. To address this, we need the mechanism to modify the question into an effective search query. Here, our language model using the function calling API can create suitable search queries. Now, despite the existence of various frameworks like LangChain and Semantic Kernel, I have personally found that the OpenAI function calling API provides a straightforward and practical approach. Challenge number 3, deciding to search or run a function. Consider that this setup operates within a chat application on various platforms such as websites, Microsoft Teams, Slack, Alexa, or even robot interfaces. In such scenarios, we don't want to trigger an internet search unnecessarily. To achieve this, we use the function calling API and we present a number of function definitions with different names and descriptions. The model then has the freedom to determine whether calling a function is justified or not, allowing for context-appropriate responses. Challenge number 4. Everyone wants to chat with their company's documents. Obviously, there's a great desire to interact with the company documents. Now, you could apply this current example by interacting with APIs such as Confluence, Stack Overflow, and SharePoint. It's important to note that these solutions rely on keyword-based searches. So if you don't get the right keyword, especially with Confluence, it will not get you the document that you're looking for. Alternatively, we use something called a vector database, which gives us the ability to use semantic search. Here you can import all of the documents, even compressed text snippets, and use the power of semantic search by querying for the concept or idea that aligns with the content. We will explore a practical example of this in a separate video. Let's talk about function call and APIs. In this approach, we give the model the power to discern when a function, which we often refer to as skills, is necessary, create appropriate search queries, and then integrate the results with the model to provide a final answer. Here's how this works. Function development. Here we create the functions that serve as additional eyes to read, or hands, actions and writing, for the model. 2. Function definitions. We define these functions in a list, specifying the function's name and description. Now, the name and description will be used by the model to determine which function is appropriate. 3. Question submission. Your question is then submitted to the large language model along with the available function definitions. 4. Function requirements. If the model determines that a function is necessary, instead of getting a normal response, you will get a response that includes the required function name and its associated parameters. 5. Function execution. The information provided by the model is used to internally activate and execute the required function. This may include internet searches or performing any other specific tasks. 6. Final answer. After the function is run, we will return to the model with the required information, and then the model will generate the final response. Let's run this. Clearly, as you can see, the model has identified the need to use a function and provided the basic requirements to operate it, as you can see. It's also noticeable that the query has been appropriately modified to align with this request. Now, while this approach is effective, it is essential to remain vigilant, as the model may sometimes suggest names of functions that do not exist. So it is always a good idea to add a conditional to ensure that the function's name corresponds with the names that you have in your definitions. And with this, you now have the flexibility to integrate various sources into your application.